Today, let's meet some engineering guys working on projects. Hey, how you guys doing?
Fine.
So, what are you guys working on?
We're working on a project for commodity market analysis.
Can you tell me more about it?
Yeah, for sure. As you can see here, we are a team. Team size without borders. As members are Boran, Renan, me, and Addison. So these are GUI layout. It's divided in two parts. The first one and the second one. The first one you can see have the commodities. So you can decide, you can choose your commodity. This could be a price index or a commodity price. After you decide one of them, a list of options will appear like right here. So you have a sort of options. And after you decide what you want, there will be set here range for data. So you have data available for each commodity. After that, you have to decide what data range you want. So you come here and decide and put the data. So with all this information, you can decide a kind of plot you want and get the results here. Here you have the graph, and after you have the prediction. So to talk more about the plot side, we listen to Boran. That's my friend.
Hey, how you guys doing? My name is Boran. So I'm in charge of the plot. So my part is basically just two push buttons and a list box. So when this two push buttons, the first one is called plot curve, and the second one is bar charts. Whenever a user clicks one, the list of choice they can have. So for example, if the user choose plot curve, they click it, and there will be a lot of choice they can have for different type of plots. So for example, the first one is called all commodity price. If the user clicks this one, so I will get whatever the commodity they choose and data range they choose, and then I will give the curve here. So and then we have a really cool function called prediction. So Ashton will tell us more about that.
Hi everybody, I am Alison and I am in charge of the prediction. This part, there are three steps in this part. First, we get the predict price from the past data available. In the second step, we get the actual price from the Wall Street Journal, and then we make a comparison in the third step between the predicted price and the actual price so that we can find the error. Now let's take a look at the code.
To start to understand the code, we need to first open MATLAB and the program. Yeah, as you can see here, this is all the code for the program. So we'll run it to see it, how it works. See it? This is the program, the layout and all the inputs here and the results here. So to begin the project, you need to select the price index or the individual commodities. After that, a list will be shown in the list box 1. After you choose one of them, data available will be set right here. With a data format like this, you have to input your data range, like after doing that, you need to select a plot line or a bar chart. So when you click one, you have a list of options here, and you click the other two, you have the two options right here. So let's see how it works in the code. First of all, we need to go to the push button callback. So you load the commodity price, that will be a .mat.m file and set for list box 1. In the push button 1, load the price index and set to the list box 1 too. So after that, we need to go to the list box callback. Here in the list box callback, you load price index and commodity price again. So you can calculate the index. That will be the column of the Excel file provided by EMF. So after that, we select the index 3, 4, or 5 to be from January 1991 to February 2013, and the index 2 and 10 to January 2092 to February 13. And And the other steps will be the part of the prediction and the plot type.
Now I'm going to explain how the prediction part works. First, we have to select a commodity in the menu, and if the commodity selected is one that we have to predict the price, the price of this commodity will be displayed here, which was calculated by using the exponential moving average and the functions polyfit and polyvol. The actual price is the price which was got from the Wall Street Journal, and the error is a comparison between the two prices obtained here. We can choose other if the commodity is not necessary to predict the price. The not available will appear. We can choose other commodity. Where is cocoa? And now we have a new predicted price for this commodity and actual price from the Wall Street Journal and its errors. According to the commodity select and by using the function polyfit, we can create a polynomial by using the last 12 months available in the data. With this polynomial, we use the function polyvol and get the price of the next month, in this case, March. To get the actual price from the Wall Street Journal, we create a function to simplify the code. This function is called getPrice. First, the specific commodity is defined as pattern, and it stops when the string appears for the first time. strcat function concatenates the strings. Then we use radius p and split the page code in two parts, before and after the pattern. Then, in the part after the pattern, we get the number in bold letter, which is the actual price from the Wall Street Journal. To calculate the error, we use this formula, and the result will be displayed in percentage.
Okay, so for plot, we basically ask user to choose the type of commodity they want, and then ask them to choose the range of data. So here, I ask user to choose from 1992 March to 1998 August. And then for the plot, we have two options, plot curve or bar chart. For plot curve, we have like 13 different options. The first one is plot every month. Just if you click that, just give every month. And the user can also choose plot this particular month. If user choose January, so the data actually you can see is not started from 1992. It actually started from 1993. So my program actually detect which year the relationship between the entered month and the graph they wanted to draw. And if you click the April, you can see the graph started from 1992 again. And also if you go back, you see the data end at 1998 August. If you click anything beyond August, you will see the data end at 1997. So how I do that, I just kind of divide it into different situations. First is like I compare the starting plot months and the actual months I want to plot, and also for every of that situation, there's two different situations for the ending month. So I kind of detect the data range ending and the months they want to plot. And then for the bar chart, user have two options: plot every quarter and every year. So if user click every year, so the bar chart just come up with three different lines. The first one represents the maximum and the minimum and the mean and the minimum, and with all the years. And also user can click every quarter. So let's see if that's getting the data range to a little bit smaller, and then click it. The user can actually see the bar charts with all the years and the quarters appear on the bottom. Okay.